Building Your Machine Learning PC. I'm Tonya Hall, and joining me is Curtis Northcutt, grad student in AI at MIT and founder and chief technology officer at ChipBrain. Welcome back, Curtis.
Hey, it's good to be here.
So, what is your mission at ChipBrain?
Yeah. At ChipBrain, our mission is to build empathy with technology. I think in 3 words. So actually, there's a really nice way that we can put it. So we've seen technology that sees, like drones. We've seen technology that hears, like our cell phones and audio equipment. But what we haven't seen and what's really missing is technology that feels and that can empathize. And so that's what we're building at ChipBrain, is technology that understands and empathizes with the emotions of humans. And there's a number of things that you can do with that in healthcare space, for patients, and selling space, and the dating space. So we're building the fundamental empathy and emotional intelligence AI layer.
You built a deep learning workstation for researchers at MIT's Quantum Computation Lab and Digital Learning Lab, and you built it for half the cost of a state of the art machine. Walk us through that. Start with defining the design goals and what components are key to addressing those goals.
Yeah, totally. So I do a lot of machine learning and deep learning at MIT. And initially, what we had to do was pay AWS to host all of our models and to run all of our training. So we did our first paper, which was, you can look up rank pruning. It's joint work with Tylen Wu and with Isaac Chuang. And it was a great paper, but it cost us around $20,000. And so I started thinking, well, hey, if I can build a machine learning rig and a deep learning rig for less than that, then I could run and do many more papers, but not have to like keep paying someone else. So I started looking into it, and I realized that I could build actually much cheaper than anything you could buy, a system that could run all of our experiments. And then it just so happened to turn out that the deep learning rig that I built was quite useful for other folks at MIT and pretty much anyone who's doing AI and training models. So I wrote a blog post and shared it, and it turned out it's been quite helpful for folks in deep learning AI.
Give us an example of a commercially available machine that you consider to be state of the art today. What benchmarks do you use and what are some of its performance metrics?
Yeah, so there's a ton of them. There's a lot of companies that are working on it. I think one of the most well-known ones is Lambda Labs, but there's a whole bunch. There's one called Bryson. I'm not sure if I'm pronouncing that correctly. There's you can usually get custom ones from some of the more well-known folks like IBM, and their prices range quite a bit. So if you bought like a 4 RTX 3090 GPU on like a state-of-the-art motherboard with a Threadripper processor, you can pay as high as like $37,000. And if you build a you can go a little cheaper and you can get something on the scale of like 10,000. It depends on how good you want your machine to be. But in terms of how do you spec out and make sure that you're getting a good deal for the amount of money you're paying, people do a lot of benchmarks. So if you're a gamer, I'm not personally using this for gaming, but if you are a gamer, you'll want to run GPU benchmarks that are there's a bunch of gaming packages online, and you can look those up on Google. I'm more focused on deep learning and AI. So the type of benchmarks I run are my own benchmarks. But specifically, all I'm doing is I'm training ImageNet, and I'm training CFAR, and I'm training a lot of the common deep learning data sets. I also train a very small language model, which is based on a Wikipedia corpus. And what I do is I train all of these the same way every time, but I do it many, many times, and then I average how fast and how long does it take to train these models. And that's a pretty standard benchmark.
Explain the key hardware elements. What subsystems and what specs should we seek?
Yeah, totally. So when you're building a deep learning rig, the main components that matter the most are the CPU, so the processor, the GPUs, the PSU, which is the power supply unit, and the motherboard. The motherboard needs to be compatible with the CPU. There's a certain number of PCIe lanes, and both the CPU, the GPU, both of them consume PCIe lanes, and they have to be compatible with the motherboard, which has a certain number of PCIe lanes. It turns out that for a lot of deep learning work, you can actually get away with not having the right amount of PCIe lanes, and so you can get some cost advantage benefits. For example, with PyTorch and TensorFlow, at least today, this will likely change as the software catches up. But for now, you can actually get away with not having enough PCIe lanes, and your deep learning will not be affected, not any measurable amount. So that's one thing. Another component is the PSU. So you have to make sure that your power supply unit can supply enough power to GPUs. And the 3090 RTX GPUs, for example, they take 350 watts. So if you have 4 of those, that's 350 times 4, 700. So that's for 2 of them. So that's 1400 for just 4 GPUs. And when you add the motherboard and you add everything, you're well over 1600 watts. The problem is that one PSU, this may be too detailed, but the problem is that one PSU is actually usually maxes out around 1600 watts. And an average outlet in a wall is 2400 watts. So you have a lot of limitations. For example, if you build more than 2400 watt machine, then you won't be able to supply power from the wall and it will shut down. And if you can't buy a PSU that's over 1600 watts, then there's that limitation as well. So there's a bunch of limitations, but the main bottleneck is going to be your GPU. So you want the best GPU you can have, you want the fastest CPU, and you want a motherboard that supports this and is compatible with all of them.
Where do you go to shop for the components, and how hard are they to find given today's chip market?
Yeah, so today finding the components is very challenging. There was a shortage likely caused by the pandemic, where a lot of the parts are originally manufactured in China. And then things shut down for a while and everything fell behind, and now everyone wants a GPU. And so things have continued to fall behind. If you search like GPU shortage online, you'll find quite a few links. So today it's very difficult to buy them. And so what I do is I do a few things. I wrote a script that scans Amazon. You don't need to write your own. If you search like a script to scan Amazon for GPU parts, you'll probably find stuff on the internet. There's a good one on GitHub, for example, that's been open sourced. But I just wrote a script, and all it does is it scans for all of the main companies that make GPUs, and it looks for the prices. And then there's a serious issue right now, actually. They're called scalpers, and what they do is they'll buy them early and then they'll sell them for twice as much. So what I did is in my script, I have a price range of what I expect to pay, and only if it's available and within that price range would I identify it. So the places I ended up buying from are the standard ones you would think of, like Amazon, Newegg. But the trick is to actually have some scripts that are running and checking all the time, because you don't want to be up at 3 a.m. trying to find a GPU.
You're up at 3 a.m. anyway, Curtis. So what operating system do you recommend?
Yeah, so I use Linux because it's pretty standardized and common for deep learning. But you can use Windows, like a lot of folks use Windows. If you're, for example, you have like a dual gaming and deep learning machine, then you probably want to use Windows. A lot of people run things on Mac. So my main setup is I have a Mac laptop, and then I SSH into a Linux server. And I have a really, really cheap Mac laptop, but I'm never running my models on it. I'm always running on the server. That allows me to have a really nice Mac experience for the lowest cost. I have like the lowest low-end M1 MacBook Air, but then I can SSH directly into my machine. That is, the highest quality machine that you can build, at least today, with 4 GPUs. And so I have the power of that machine, but on my cheap little M1 MacBook Air, and that gives me the power of one with the nice experience of the other.
What about overall system cooling? How do you handle that?
Yeah, so that's a great question. So cooling is I have very strong thoughts on this, which maybe I should be careful about sharing, with you all. But so for cooling, what a lot of people do is they're about aesthetics. But I want to build technology that works, and I want other people, other researchers, to be able to compete with some of the larger companies. And I want a young new researcher with limited funds to be able to build and to train an AI model that's advanced to be able to publish research in their field. So my focus is not aesthetics, and water cooling is about aesthetics. And here's why. If you can build a GPU rig that's an open air case that takes up a lot of space and the GPUs are very far apart, then there's lots of air passing through and you don't need water cooling. The reason you need water cooling is when you want to pack all of the GPUs very tight together within a very confined space inside of a small case, and the idea is that it looks better. But the idea is if your goal is to be in research and to be in AI and deep learning, and you don't care so much about looks, you actually don't need water cooling. You can save a lot of time and a lot of hassle and just use an open air case. So that's what I've been doing. Before I was doing that, the trick that I would use is I used blower style GPUs. Which blow the air out horizontally instead of having the hot air sort of hit each other and slow each other down. But it's slightly a farce. The blower style GPUs still will slow down. They still will bottleneck. So what you really want is an open air GPU case.
Curtis Northcutt, grad student at NAI at MIT, founder and chief technology officer at ChipBrain, and master machine learning computer builder. If somebody wants to connect with you, Curtis, maybe they want to find out more about the work that you're doing, and or maybe they want to just listen to some of your rap music. Um, what's the best way they can do that?
Yeah, sure. So for the rap music, you can check out Palm BP, the PhD rapper, on YouTube. And for reaching me, a great way to reach me is through my blog. It's l7.curtisnorthcutt.com. And the L7 blog is a blog for machine learning. So if you were to search Google for L7 machine learning blog, you'll find my blog. On there, there's a contact form, and I always respond to folks who reach out. So please say hi.
It's always fun and informative to have you on, Curtis. Thanks for joining us.
Glad to be here.
And find and subscribe to more of my interviews right here on YouTube, iTunes, Spotify, Stitcher, or at tonyahall.net. Thanks for watching.